Hello, beautiful people, and welcome. In today's video, we are discussing trig identities, specifically reciprocal identities, tangent and cotangent identities, and the Pythagorean identities. We are then going to take the identities and use them to simplify expressions and use them to verify other identities. So let's go ahead and start out with reciprocal identities. Now, if you're in my class, you have seen these before. That's when you take it and flip the fraction, which is what a reciprocal means. So we have reciprocal identities. Now we know that sine is the reciprocal of cosecant, cosine is the reciprocal of secant, tangent is the reciprocal of cotangent, and vice versa. So how to write those out is we have sine of theta, you can also write x if you'd like, is 1 over cosecant of theta. Cosine of theta is 1 over secant of theta. Tangent of theta is equal to 1 over cotangent of theta. Now again, we can go forwards, we can go backwards, so let's go ahead and rewrite the other three. So that means cosecant of theta is equal to 1 over sine of theta. Beautiful people, I'm going to jump in here real quick and interrupt this video. The next thing that I say in the video is a repeat. So originally we had cosine of theta is equal to 1 over secant of theta. And when I was showing you the other way around, I accidentally wrote the same thing twice. So what it should say is secant of theta equals to 1 over cosine of theta. So in your notes, please write secant of theta is equal to 1 over cosine of theta. I do end up correcting this later on in the video, but as of right now, please write that. Please do not repeat this. Thank you. And cotangent of theta is equal to 1 over tangent of theta. Next, we have the tangent and cotangent identities. Now, if you're in my class, you have seen these before. And that is when you have tangent of theta equaling sine of theta over cosine of theta. And that comes from our special right triangles where we have the ratio of sine being opposite over hypotenuse, the ratio of cosine being adjacent over hypotenuse, and then we simplify that fraction, leaving us with just sine over cosine. Now we can also take the reciprocal of that, so switch it, meaning that we have cotangent of theta, which is the reciprocal function of tangent, equaling, flip the fraction, so cosine of theta over sine of theta. Now the next identities we will focus is on the Pythagorean identities. And just like the name implies, we will be doing some a squares and b squares equaling some c squares. There are three main Pythagorean identities. First one we have is sine squared of theta plus cosine squared of theta equals 1. Next we have, let me shift this paper up. Oops, sorry about that. Next we have tangent squared of theta plus 1 is equal to secant squared of theta, and cotangent squared of theta plus 1 is equal to cosecant squared of theta. Now, because this is an equation, we can rearrange these to however we want it to, basically. The only thing we have to keep in mind that there is a pattern, a squared plus b squared equals c squared, just like with the Pythagorean theorem. So notice for all of these functions, we do have something squared. So later on when we're trying to simplify expressions, one of our checks, our mental checks will be is, do I have anything squared? If I have something squared, perhaps it is a Pythagorean identity. So let's go ahead and rearrange some of these. So let's say I take the first one and I'm going to subtract cosine. I'm not going to write it down, but I'm going to subtract cosine from both sides. So that gives me sine squared of theta equals cosine squared of theta. What was I subtracting? I was subtracting cosine. So let's go ahead and say 1 minus cosine squared of theta. I apologize for that because we're subtracting cosine. So cosine negative minus would go behind 1. Now let's go ahead and subtract sine. So we have cosine squared of theta is equal to 1 minus sine squared of theta. And yes, order does matter. So if you put that 1 behind cosine, that would be wrong. So you have to have 1 minus cosine squared here, 1 minus sine squared here. Next, we can rearrange this one. I can subtract 1 on this, so we can have tangent squared of theta is equal to secant squared of theta minus 1. We can also subtract tangent and say 1 is equal to secant squared of theta minus tangent squared of theta. And again, order does matter, so you can't put tangent minus secant. That would be wrong. Next up we have, I'm going to write this a little lower for space. Let's subtract. So here's cosecant squared of theta. Let's subtract 1. And that's equal to, I'm going to stay with the pattern, cotangent squared of theta. So what I did here on this side is I subtracted 1, leaving cotangent squared of theta by itself. So we have cosecant minus 1. Now if I just leave 1 by itself, subtracting cotangent, that gives me cosecant squared of theta minus cotangent squared of theta. Now this is not the only way that you can rearrange it. We can also leave things negative. For example, I can have a negative cotangent and rearrange these. So there's many different ways to rearrange them. Don't think that you're limited to just these. Okay. So why do we need them? If we are given an function, so if we are given like sine, cosine, tangent, secant, cosecant, and we need to rewrite it in a simpler form, we will use these identities to help solve. So, example 1. Use trigonometric identities to write each expression in terms of a single trigonometric identity or a constant. So step number 1 on how to do these. First thing, step number 1 is always to look and rewrite things in terms of sine and cosine. Then you want to see if there's anything squared. If something is squared, we're thinking identity, Pythagorean identity to be exact. So let's start here. Step number 1, you want to look and rewrite things in terms of sine of x and cosine of x. Now I'm writing x. If they're giving you theta, you can choose to keep it as theta or you can choose to change it to a x. It's up to you. All right, let's go ahead and do that. So tangent, this is not squared, so not Pythagorean identity. Tangent, we know by the tangent and cotangent identities, is sine of theta over cosine of theta. This is being multiplied by the original cosine of theta. Now, because I'm multiplying a whole function by a fraction, I'm going to put a 1 underneath it, and we're just going to multiply across. Now, some of you are saying, oh, the cosines, can we cancel out the cosines? Yes. Actually, with multiplication and division, you can do what your heart desires, and that is to divide the cosines from the bottom and the top. I'm going to continue writing this out together to show you what happens. So you have cosine times sine, or sine times cosine, over cosine times 1, which is just cosine. Cosine and cosine, they divide out, so we're just left with sine of theta as your single trigonometric identity or constant. Next up, we have alert, alert, alert. Do you see that squared? That means red flag. right? That means a red flag. We're going to check if any of those match our Pythagorean identities. Now, step number one is still to rewrite things in terms of sine and cosine. But I see I only have cosine, so I can't really do that step number one because there's nothing to rewrite as sine and cosine. They're already there. So Pythagorean identities, here's our cheat sheet, and we're looking for 1 minus cosine squared of theta. So I'm looking here because that's the only one that has cosine in it. And I'm looking for 1 minus cosine. Oh, there it is. So 1 minus cosine squared of theta is equal to sine squared of theta. So I'm going to rewrite this as sine squared of theta over my original cosine squared of theta. Now again, alert, alert, alert. We still have that squared function, but I also know I have a sine over a cosine. That rings a bell for me. Let's go back to our cheat sheet. Tangent is sine over cosine, but I have it squared. You know what? That's actually okay. So because I have sine over cosine, although both of them are squared, because both of them are squared, if it was only one that was squared, it wouldn't work. Because both of them are squared, I can actually rewrite it as tangent squared of theta. All right, let's do some more. Taking a look, step number one is to rewrite things in terms of sine and of cosine. So I have cosine, so that's fine. Nothing wrong with cosine. And now I have cosecant. Now I know that cosecant has a relationship with sine. They are reciprocal functions. So cosecant, if you don't have that memorized, is a reciprocal identity. Cosecant is 1 over sine. So you're going to rewrite cosecant as 1 over sine of theta. Now, just like in example 1, we do have a whole function multiplying by a fraction. So I need to go back and make this cosine into a fraction. We're going to multiply across. Does not look like anything is able to cancel out like that other example, but I'm seeing sine and cosine. I know that tangent is sine over cosine. So what's the flip? What's the reciprocal of that? And the reciprocal of tangent is cotangent with cosine over sine. So because we have cosine over sine, that means we have cotangent of theta. These two are not squared, so this one is not squared either. It was just the other example where both were squared. Go ahead and move on to the next one. Sine of theta times secant of theta divided by tangent of theta. Again, step number one is rewrite things in terms of sine and cosine. So I have sine of theta times secant. Now I know secant and cosine have a relationship with each other. What's that relationship? It's a reciprocal relationship. So that means secant, where's secant? Oh, do you see how I messed up here, beautiful people? Let's make that change. That should have been, do you see how these are exactly the same? I never actually flipped it. So let's go ahead and change this real quick. So let's do secant of theta is 1 over cosine of theta. I apologize for that, but now we know that secant of theta is 1 over cosine, so let's write that in. And that's still being divided by tangent. Now we have to change tangent into sine and cosine, so tangent is sine of theta over cosine of theta. Okay, let's combine. Once again, we have a whole function. We're going to put a 1 underneath it, multiplying by a fraction. Now you can do this in one step. I am going to just show you one step at a time here. taking a little bit more time. That's okay. So now let's combine it. We have sine of theta times 1 over 1 times cosine of theta divided by sine of theta over cosine of theta. Okay, now you have a choice to make. You can either see that these are the same, top and bottom is the same. That means that we have 1. If you accidentally didn't see that, we can always do keep, change, flip. So I'm going to rewrite this here. So sine of theta over cosine of theta divided by sine of theta over cosine of theta. That's equal 1 because these are the same. And if we're dividing, same thing, it always equals 1. Now, if you didn't see that and you wanted to do keep, change, flip, our division of fractions, you can do it and still end up with the same answer. It's just going to take you an extra step. So keep, change, flip. For this question, this is optional. You didn't have to do this. We have sine of theta over cosine of theta. We're keeping that. We're changing that to multiplication. And then we're flipping that as cosine of theta over sine of theta. Then you can see that the cosines go away, the sines go away, and if you give me 0, I'm going to chuckle and mark it wrong, right? It's not 0. Sine divided by sine is 1. Cosine divided by cosine is 1, so our answer is 1. But I think noticing that it's the same thing top and bottom is easier and it saves you a little bit of time. Speaking of the keep, change, flip method, let's see how it works with just regular numbers. Slow it down just a bit. So let's say we have a fraction divided by a fraction. We are going to keep the top fraction. We're going to change that division into a multiplication. And we're going to flip the bottom fraction. So we have, for this example, 2/3 times, flip the fraction, 15 over 4. Multiply things across. Now you can actually multiply it and do like 30 over 12. That's fine. Or you can keep it and see if things simplify before multiplying. It's your choice. And we have 30 divided by 12. Simplify that, and that equals to 5/2. Let's go again. We have keep, change, flip. So we're keeping the 1/2. We're changing that to multiplication, and we're flipping it. But wait, 2 is not a fraction. So what are we flipping? Well, you're still taking the reciprocal of that denominator. So if we have 2, the reciprocal of 2 is 1/2. So you're still flipping it. And so we have our 1/4 here. Oops. Okay, let's go again, but now with trig functions. Step number 1 stays the same. Rewrite everything in terms of sine and cosine. So cosecant has a relationship with sine. So I know the relationship is a reciprocal relationship. So I have 1 over sine of theta. And let's actually change this to a different color so it can stand out. And cotangent is the reciprocal of tangent. So I know tangent is sine over cosine. The reciprocal of that is cotangent, which is cosine over sine. Okay, keep, change, flip. We have a fraction divided by a fraction. So we're going to keep, we're going to change, we're going to flip. So we're keeping the first one, 1 over sine of theta. We're changing that to multiplication, and we're flipping the bottom to sine of theta over cosine of theta. Now your heart is screaming at you. Look at the signs, look at the signs. No pun intended. But look at the signs. We got sine on top, sine on the bottom. We are multiplying. So your heart desires to cancel them out, right? It's not a mathematical word, but we do want to cancel them out. So let's do that. We have sine of theta over sine of theta times cosine of theta. Now be careful when you quote unquote cancel things out, when you divide out. It does not become 0, it becomes 1. So our answer is, I'm going to write it here, not to go into the other space, 1 over cosine of theta. But screaming at you, that's a fraction. That's a fraction of a reciprocal, right? So what's cosine relationship with a different function? Well, cosine and secant has a relationship with each other. What kind of relationship is cosine and secant? A reciprocal relationship. So that means we take it one step further to secant of theta. Let's go again. Alert, alert, alert. We have a squared. I know, beautiful bee, I'm being extra. It's okay. Okay, when you see that squared, immediately think, is this a Pythagorean identity? Perhaps. Let's take a look. What kind of Pythagorean identities do we have? We have a 1 minus cosine squared of theta. Do we have that as one of our identities? We do. 1 minus cosine squared of theta is equal to sine squared of theta. So we're going to rewrite all of this as sine squared of theta. Now I do see a tangent. Tangent is squared. But before I use tangent's Pythagorean identity and call it secant squared minus 1, I'm just going to try to use the I'm going to try to use the tangent cotangent identities to see if that helps me out. A lot of times if it's singular squared, you want to use those identities before you use the Pythagorean. If you see a binomial, then it's the Pythagoreans. Not always true, but sometimes true. Okay, so tangent is sine of theta over cosine of theta. Now notice that I kept it squared. I don't have a tangent of theta, I have a tangent squared of theta. So when you rewrite tangent, you have to rewrite tangent as sine squared of theta over cosine squared of theta. Okay, now let's do our keep, change, flip. We have a keep, we have a change, we have a flip. So let's separate this out so I don't get confused. We have sine squared of theta times, we're going to flip that to cosine squared of theta over sine squared of theta. Again, hopefully your heart's screaming at you already. Look at the signs, look at the signs. So let's look at the signs and say, yes, indeed we can divide them. So we have 1 times cosine divided by 1 times 1. We just have cosine squared of theta for our answer. Okay, moving on. We're going to go a little bit faster now on these examples. Step number 1, rewrite things in terms of sine and cosine. I already have a cosine here. Secant is the reciprocal of cosine. So secant is 1 over cosine. Tangent, hopefully these are starting to commit to memory. You're starting to commit these to memory. Tangent is sine of theta over cosine of theta. Now before we do our keep, change, flip, go ahead and simplify the numerator. I see a cosine squared of theta over cosine squared. Sorry, I keep saying squared. It's not. Just cosine of theta over cosine of theta, not squared here. And that just happens to be 1. Let's go ahead and do this. Sine of theta over cosine of theta. So we have 1 over sine of theta over cosine of theta. So we're going to keep, we're going to change, we're going to flip. So we are keeping 1, we're changing to multiplication, and we are flipping from cosine of theta over sine of theta. This is just being multiplied by 1, so it stays the same as cosine over sine. And hopefully, again, that's starting to ring a bell now. Cosine over sine is the reciprocal of sine over cosine. Sine over cosine is tangent, so since we have the reciprocal of that fraction, that means we have the reciprocal function of cotangent of theta. Okay, next one. We have sine of theta over cosecant. Since we already have sine, we don't change that. Cosecant, however, is the reciprocal of sine. So that means we have 1 over sine of theta. Keep, change, flip. Keep the sign. Change to multiplication. Flip the bottom. Make it into a fraction if you need to. Sine times sine is sine squared of theta. Moving on to something that's a little bit more difficult to see. It's factoring. Now you will need to factor with trig functions. Factoring uh, does occur frequently enough that we are going to be testing on it. So be careful on that. So let's start with basic factoring. Let's say I have a squared minus a squared b. So factoring is removing the common factor. I have an a squared, I have an a squared. So I'm going to remove that a squared or divide by that a squared, factoring it out. So I have a squared divided by a squared, which is 1, minus a squared divided by a squared is 1, leaving b. So these are our factors. Now we also have factoring like this, where we have the guess and check method. Now this is also a pattern if you don't recall the pattern. So let's do guess and check and see what the pattern ends up being. So I want to guess two numbers that multiply to 1 but add up to a -2. So we know this is going to be x and x. Two numbers that multiply to 1 add up to -2 is -1 and -1. So this is your squares pattern, right? The x minus 1 can be rewritten as x minus 1 squared. So let's see examples here. Example 1, or example A, we have a cosecant squared of theta. We see that exact same cosecant squared of theta here, and we have a minus cosine squared of theta. But Ms. Romadez, you said to change it into terms of sine and cosine. Yes, if you do that in step number 1 for this specific example, it actually will complicate your life a bit because now you're going to have to remove fractions. So because I'm seeing I have a cosecant and a cosecant, I'm going to choose to factor first, then deal with converting things to sine and cosine and perhaps even using other identities. So let's remove that cosecant squared of theta, leaving us with cosecant divided by cosecant, that's 1, minus cosecant cosecant, that's 1, leaving us with cosine squared of theta. You should have an alert now. We've seen this specific one a few times. Why is it only this one? I don't know. Just happy accidents. So 1 minus cosine squared of theta, we look at our cheat sheet, 1 minus cosine squared of theta is equal to sine squared of theta. So we can rewrite this, all of this bubble, as sine squared of theta. And we know that cosecant squared of theta has a relationship with sine. What kind of relationship is it? It is a reciprocal relationship. So cosecant, let's make it green, is 1 over sine squared of theta. Multiplying it out, let's make this into a thinking bubble so you know where the other one came from. So what do we have here? we have a fraction, so let's put a 1 underneath it. 1 times sine times 1, so we have sine squared of theta, over sine squared of theta. Same on top, same on the bottom. Our answer is 1. Let's go again. This time it's actually not asking you to factor, but instead it's asking you to multiply. Now you have a choice to make. You can memorize the pattern, or you can use the box method. I highly encourage you to distribute and memorize the pattern instead, but let's do the distribution and then I'll show you the pattern later. Sine times sine is sine squared of theta. Sine times cosine is a positive sine of theta, cosine of theta. Negative cosine times sine is negative sine squared. Sorry, I keep saying squared, it's not. Sine of theta, cosine of theta. And the very last one, will I have enough colors? Perhaps. Negative cosine times a positive cosine is a negative cosine squared of theta. And so the pattern is you take the A value, which is sine of theta, square it, minus your B value, which is cosine. Your middle terms, these here, will end up subtracting out. You have sine cosine minus sine cosine. That's gone. So you're just left with sine squared of theta minus cosine squared of theta. Okay, so let's take a look. Perhaps that is an identity. Let's see here. I have sine squared of theta. Oh, it's not an identity. So I thought this was an identity for a quick second, but look, we have addition for an identity, but we do not have subtraction. So because it is subtracting, it is not an identity. Now, maybe we can mess around with it and see, but because we have subtraction, messing around with it will be requiring us to do common denominators. Okay, I'm going to leave this one here. Towards the end of the video, if we have time, I'll go back to it and see if we can play around. We can play around with it some more, but as of right now, I'm going to leave it and move on for the sake of time. We just have a few more left, and then we can come back to this one. All right. Now we have tangent of theta plus 1 squared. Again, you can have the pattern memorized. If not, that means you have tangent of theta plus 1 times tangent of theta plus 1. Now this is not like the other one. The other one was the difference. One was addition, the other one was subtraction. This is both addition. So I encourage you to distribute. Tangent times tangent is tangent squared. Tangent plus 1 times a positive 1 is a positive tangent. 1 times tangent positive is a positive tangent. Lots of tangents here. And 1 times 1 is a positive 1. So we end up having tangent squared of theta plus 2 tangents of theta plus 1. So here we're just multiplying it out. All right, next up, we have our factoring. This is the one that requires some pattern. If you're uncomfortable with the sine squared minus 2 sine of theta plus 1, you can change it to x squared minus 2x plus 1, where x is equal to sine of theta temporarily. Right, we do a temporary change. Ooh, we got some shadows on here. Okay. So since we have this one here, how would we proceed to it? Well, we did something very similar. We would do guess and check. So what two numbers multiply to 1 but add up to a -2? So we said it was -1 and -1. So then we would use that to factor our original with sign. So we would then say sine of theta minus 1 sine of theta minus 1. So that means we have sine of theta minus 1 squared. Okay, we got two more. And this time we are verifying the identity. So verifying the identity is taking only one side and working with one side. There is no answer. The answer is already given to you. So we have to make both sides equal. Now, my recommendation is do not mess with both sides. Choose one to work with. Choose one of the sides to work with. The side that you seem is going to be more or less complicated, right? It's going to be less complicated, then do that one. And make it equal, make it fit to the other one. All right, let's choose this one. So this one, I think it's pretty straightforward which side to choose. You can't really do anything with one. So let's go ahead and choose this one. Step number 1, rewrite things in terms of sine and cosine. Hopefully you have some of the identities memorized now. We have cotangent of theta, that's the reciprocal of tangent, so we have cosine of theta over sine of theta. And secant has a relationship with cosine, so we have 1 over cosine. Making everything into a fraction, we have sine of theta times cosine of theta times 1 over sine of theta times cosine of theta. So I'm just multiplying across. Equals 1. So we have 1 equals 1. Therefore, we have verified the identity. Last question here. Okay, which side do we want to work with? I don't know. We have 1 minus 2 sine squared of theta, and we want to make it look like 2 cosine squared of theta minus 1. So this one here is a little bit on the more challenging side. So let's work with it on a slower pace. I have 1 minus 2 times sine squared of theta equaling 2 cosine squared of theta. I'm going to choose this left-hand side to work with. If you want to choose the right-hand side, that's fine. It just will be different. So for your left-hand side, there's not really much we can do. Somehow I need to get sine into a cosine because I have a cosine here. So I'm going to change out sine squared of theta using my Pythagorean identity. So sine squared of theta is equal to 1 minus cosine squared of theta. And I'm going to get a cosine that way. So 1 minus cosine squared of theta. Now I have a 2 that I need to distribute. So 1 minus 2 plus 2 cosine squared of theta. This is just subtracting. We have -1 plus 2, let me shift this up, cosine squared of theta. I'm going to rearrange it. So we have 2 cosine squared of theta is equal to 2 cosine squared of theta. Oops, and I forgot my -1 here, so let's put it in right over here. -1, and we have a -1. That's going to bother me. I'm going to have to rewrite it. So we have 2 cosine squared of theta minus 1 equaling, oops, let's bring this down. Two cosine squared of theta minus 1. beautiful people, I promised you that I'd come back to this question, and at the end of the video, I did forget, so I apologize for that. Let's go back to it. There is one more step they do want us to do for this question. So this is not your final answer. This is for B. So because we are left with sine squared of theta minus cosine squared of theta, it is not one singular function. We can see that we have sine and cosine. They want our answer in the form of one singular function. So we are going to choose either to rewrite sine or we're going to choose to rewrite cosine. So let's take a look here. I can do cosine as 1 minus sine squared of theta from the Pythagorean theorem, or I can do sine squared of theta is equal 1 minus cosine squared of theta. It's up to us. So this technically could have two answers. So let's say I choose to rewrite cosine. Let's say this is what we're choosing. So we have sine squared of theta minus, and now I know that cosine squared of theta is 1 minus sine squared of theta. We do have a negative that we need to distribute. So we're left with sine squared of theta minus 1 minus sine squared of theta. Let's rearrange it a little bit. So we have negative 1 plus sine squared of theta minus sine squared of theta. My two sine squared of thetas, they undo each other. One's addition, one's subtraction. And we're left with just negative 1 as our answer. Now, if you did choose to rewrite the other one, it could have given you a different answer. All right, beautiful people, thank you so much for your time, and I will see you in the next video. Bye.